Hello, welcome to lecture series on the course Strength of Materials or Mechanics of Materials. Today we will be speaking about simple stress and strain. My name is Dr. Shiv Shatanya Swami. Let us consider objectives of the session. To understand the behavior of solid bodies subjected to tensile loading, compression loading, also to know the properties of materials. Outcomes of the session will be to know the tensile loading, compression loading, then understand the behavior of a materials, ductile or brittle in nature, also the mechanical properties. At the end, we will be taking some numerical. Outline of the session is introduction, general meaning of stress, stress, types of simple stress and strain, then stress strain diagram, numerical. So now let us consider a simple mechanical member or a device which everybody will like is a bicycle or a bike. See here you can observe many parts are made up of different materials. Okay, this is made up of a rubber, this is made up of a metallic nature, this is again a plastic or a polymer, this again a grips are made up of a polymer, etc. These are all made up of metals, which there we need stiffer material or a tougher material. Got it? So why these different components of a bike are made up of different materials? Let us take one more example, bike. You can observe here there are a number of components are present here, but they are not made up of single material. What may be the reason? Definitely question arises here, correct? Yes, because in the mechanical component all members are not subjected to uniform stresses and strains. Again, let us consider some other components of car. Wonderful. Here you can see there are number of parts are there. Is it possible to count? Yes, if it's possible. But now you can observe here a lot of components are present with the different materials, the different shapes and sizes. Why it is so? Okay. Next, let us take an aeroplane. Here also number of parts are there, but again here not made up of single material. Yes, now it is necessary for us to think. Okay, look at here. Let us have a small activity. Observe the materials based on color in a aircraft component. Here we have three colors. One color is FRP, that is aramid fiber reinforced plastic, carbon fiber reinforced plastic. Next one is GFRP, that is glass fiber reinforced composite. Based on the color you can see which component of the aircraft is made up of which particular material. Here all these materials are composite materials. Okay, so they are lightweight structure, also the good strength property they possess, so they are using this. Okay, but still now why different materials or different components? The reason is very simple. Here we need to have to observe as an engineers which are the components, which are the materials are subjected to what are the different types of stresses. Okay, based on that materials will be selected. Here two aspects come into picture. One aspect is stress analysis of a bodies under the action of external forces, also to determine internal stresses and their deformation. Very important. Based on this particular part, materials will be selected for different components. One more aspect here is Yes, while selecting a different component, we need to know material strength, stability, fatigue, and brittle fracture it possesses or not, etc. We need to observe. Yes, guys, it is compulsory to know mechanical properties before selecting any material for particular design of a component in a mechanical structure. Yes, now let us take up with the review of statics. Statics is a branch of mechanics of materials, is a branch of mechanics that develop a relationship between external loads applied to the deformed body and intensity of internal forces acting within a body as well deform a body. Then equations of equilibrium are, there are two mathematical expressions with respect to vector relationships showing the body not to translate or move along the path. Then the force summation of forces along a particular direction is equal to 0. Also summation of a movement is equal to 0. Okay. So what is a rigid body? Rigid body is defined as a body which distance between 2 points never changes whatever may be the force applied on it. But in practically absolutely not possible to identify any rigid body. Okay. Next. Now, how the stress will induce? Imagine a body is there. For this, we are going to apply a external force. Then, due to this equilibrium condition, internal forces or moments will develop. Then, here the stress will induce at the corresponding cross-sectional area. So now you can give the stress, call this as a normal stress. The normal stress is given by, it is the unit force for perpendicular cross-sectional area. Okay, perpendicular cross-sectional area. So this A you need to take, this force you need to take, then you can calculate this sigma normal. Okay, then how actually this area must be? Let us take one more example. This is a uniform cross-section area you have to take. The cross-section area can be obtained by the taking a section, okay, as shown in the diagram. So once you take a section, if to determine the stress, we need to use corresponding area. If you take a circular bar, so look at there, the two forces are actually applied opposite to each other. It is called as tensile stress. Okay, so this is how the stress will. What happens once the force applied here? What about the molecules? Please observe here. This is how the molecule dislocation takes place. This is the reason where in a ductile material you can observe this type of necking formation in the ductile materials. Now, what is stress, guys? Normally, stress has two components. One is acting perpendicular to the cross-sectional area, another one is parallel to the cross-sectional area. Mathematically, the one which is creating a pulling action, it is called as a tensile stress. The one which is acting pushing action, it is called as a compressive stress. Tensile stress will be always denoted by a positive. Compression stress will be always denoted by the negative. So the normal stress is given by sigma. Shear stress, which is acting to the parallel, is given by the tau equation. So it's a component expressed as a shear stress, which is intensity of internal forces acting a tangent to the increment the cross section area. So then you can call this as a tau value. Hope now you understood how actually the and stress can be found, guys. Let us see here. Once you apply a force, if it is towards each other, then that particular member you can call it as a compression. If it is away from each other, then you can call it as a tensile stress. Once your force will apply, then due to this tension, the stretching takes place. Means original length, light increase in a deformation takes place. Okay, so at that point of time, the prismatic bar, you can calculate a stress by taking a force applied to cross section area ratio. Okay, so now look at here. This is how the elongation takes place in a body. Okay, now let us come across what is normal stress and normal strain. Normal stress is given by force by area, whereas strain can be given by whatever the elongation length is there, change in the length to original length we have to take. Okay, so similarly, now let us have a small exercise here. If area doubled, force also doubled, is there any change in a stress in a member? Let us see. Force is 2p, area is 2a, then again stress will remain same. Okay, and also strain also will remain same. Okay, again one more exercise. The length is doubled, deformation is doubled. At that time you will get same stress value, then same strain value. Okay guys, with this you will come to know that stress is not dependent on length. Okay, stress is not dependent on length. Okay, so here you will come to know that the stress and strain are internal effects. Okay, now let us go here how actually tensile stress will be conducted. Okay, so please observe the video here. So these are the different material specimens for different components, how you can find out the tensile stress. Okay, so these are all tensile test specimen. Okay, so here you can say this is a bronze, aluminium, steel, then flat aluminium member, then flat strips, etc. Okay, so here if we find the apply the force due to the ductility property, what will happen here? Necking formation will takes place. With that you can go for a finding a stress, guys. Okay, so now let us see one more sketch here. Here a strip will be subjected to tensile member. What's happening? Once you draw a strain versus a stress diagram, you will come to know yielding takes place after a point B. Up to A to B, the stress is directly proportional to strain. Okay, now please observe here. If you conduct a tensile test, you will be getting a mechanical behavior based on stress strain curve, how it is coming. Okay, here the zone you can see at the all these particular point, wherever the material is weaker, at that location necking formation will take place, then material will break. Okay, next please observe here. So what are the different properties you can study here? Now first let us come to know what is meant by a stress strain curve. It is one of the most important tool in a structural engineering. Every solid material has its own unique stress strain curve, guys. So by understanding the how to interpret the curve, you can get insight over how better design products to survive the loading. So here it's very important to understand the stress strain behavior of the material. And here we have some of the definitions. Let us see how we can find them or understand them. First, stress. Stress in a structural engineering is measure of amount of force applied to cross-sectional area. Then strain is nothing but it's a measure of material deformation to its original length. Then proportional limit. So guys, you can see here it is a proportional limit. This limit is nothing but at the particular stress, proportional limit stress you are going to get. It is the area under the curve. Okay, proportional limit area under the curve before it reaches elastic limit. In this area, Hooke's law can be applied. What is Hooke's law? Hooke's law states that whatever the stress is there, it is directly proportional to strain within elastic limit or a proportional limit. Then what is elastic limit? It is again a point which is slightly additional to the stress causes a permanent deformation. So slightly above this we will be having a elastic limit. Next, what is yield stress? Yield stress, the stress at which material will retain 0.2% of elongation after the stress or force is removed, means almost entering to the permanent deformation. Next, what is ultimate stress? Ultimate stress is the one where maximum stress a material can withstand. It's a maximum amount of a stress where a material can withstand. Next, fracture limit. Look at here, this is a fracture limit. This limit, always fracture limit stress for the material will be lesser than the ultimate strength. Okay, so this is the point at which material will fail catastrophically through fracturing. Okay, what is elastic region? The elastic region is a one. This is elastic region up to elastic limit. Whatever the we have, that's called as a elastic region. The region where the stress is released from the material, it will return to original state. Then that particular region is called as a elastic region. Within this only we will be defining Hooke's law. Okay, also within that only we will be saying that it is having a elastic behavior. In this part it is a linear elastic behavior. Okay, so now what is a plastic region? Plastic region is where the stress is released in uniform in the form material. It will retain a permanent deformation. Okay, so it's a particular plastic region is there, na? So in this region where material will definitely in a permanent deformation, it will not regain its original shape and size. Okay, then what is stress hardening? Stress hardening occurs when the material experiences plastic deformation, means the stress will be there. Hardening means permanently moved to the particular state in any point of stress strain curve. Your necking. Necking is the one particular phenomena after the ultimate in the limit, but wherever the material is weaker, it is going to shrink the area or a necking region. So then that is called as a necking formation. Now let us observe what is Hooke's law, guys. Hooke's law is defined only within elastic limit. Okay, so this is a stress region, this is a strain part. So when you take a slope, okay, The slope is given by stress to the strain. Okay, sleep, the whatever the constant is there, stress is directly proportional to strain within elastic limit. At that time, with the elastic proportionality constant will be replaced by a constant, that is a E. So at that time, E is equal to stress through strain value. So the E is the slope curve, guys. So E unit is again similar to the stress unit whatever we are using. So normally it will be expressed in terms of a Newton per millimeter square if area is in millimeter square. Okay, so now if the material is observed to be cup and cone failure fracture, then it can be said as ductile fracture. Then if a material fails in this particular format, then we can call this as a brittle fracture. So up to here we discussed what is a stress, what is a strain, then we discussed about different definitions. Then again at the end we came to know what is the Hooke's law. Hooke's law is defined as stress is directly proportional to strain within elastic limit at constant temperature and pressure. Okay, so now later we ended with the studying ductile and brittle materials. Okay, so with this let us stop the session.